All right, guys, so today we're going to talk about something called properties. Okay, and this lesson's a little different than a lot of our other lessons. You'll see why in a bit. It has a lot to do with vocab, so we're going to spend like a huge chunk of our lesson is basically vocabulary. Now, with properties are math rules that are true 100% of the time. Not most of the time, 100% of the time. So for example, believe it or not, most of these rules, maybe not all of them, but most of them, you guys already know. Okay? So for example, here's a rule. If you add 0 to something, let's say to 3, what do you get? 3. Doesn't change anything, right? That's a rule, hopefully all of you guys know that you might have learned in like kindergarten, right? Maybe even before that. Okay? How about like 3rd or 4th grade, when you talked about multiplication, you have a number and you multiply by 1. So let's say 5 times 1, what do you get? 5, right? So whatever you start with, you multiply by 1, you get the same thing. Okay, so those are some rules that, like I said, you guys are already aware of. Today what we're going to do is we're going to give them names. All right, they're specific mathematical names. Now you might go, why do we need to know this, Mr. Wilkins? Well, a couple of different main reasons is because, first of all, there might be some rules that you don't know that will make your life a little easier when you're calculating. A lot of us like mental math, and properties sometimes will help us with that. The second thing is we're going to see a 7th grade twist to it. We're going to see variables, right? We've talked about algebraic expressions. We're going to see some algebraic expressions in these properties. So you have to, sometimes when we see, a variable, multiplied with 1, that might freak us out. But if it's b times 1, it's still going to be b. It's still the same thing. Okay, so that's kind of the new twist to it as well. So, for example, I was telling you how it can make your life a little easier. Here's another example is this. And I say quick. Here we go. Let's see how fast you guys can solve this problem. Go. Anybody? Anyone know that's 210?
Yes.
Okay. I know it's 210 because, why? Because I used a property knowing that I can multiply the 5 and 6 to get 30. 30 times 7. Well, 3 times 7 is 21. You put that extra 0 back there, 210. Most of us probably said, okay, 5 times 7 is 35. 35 times 6, so 5 times 6 is carry the 3. Okay, and that you don't have to do all that. Try to do that mentally. Okay? Because, I just use like another rule, right? You multiply by 10, you just add the 0 on. That's another math rule. So I kind of combined a couple in there, but that is an example of how to use properties properly. It can help you. Okay, so it's just kind of an example of what we're getting into. So here we go. You have your notes out in front of you. You have your 2 folded papers. You might want to put them side by side with the windows because that way you can have an easier time finding them. All right, so here we go. Before we get started on this first set of properties, okay, and when I say a set, it's because there's some similarities between them. They have the word commutative in it. So first one is commutative property of addition. Everyone?
Commutative property of addition.
All right, so of course make sure you find that. Now before we write down some examples, let's talk about the word commutative. Think about it. What would be the root word? Does anybody know? Commute.
Yes.
What does it mean to commute? Like if someone has a job out of town, they commute. You hear they commute out of town for their job. What would that mean? No one's ever heard the word commute? To commute, to travel, to go from one place to another. Okay? And that's kind of what this property is saying. It's kind of like taking a number and making it travel. Okay? Or being able to move it. All right? Now here's what it specifically means, okay? I tell you what, before I tell you what it specifically means, let's go ahead and write that down in your little box there, okay, behind your window. Commutative property says that 5 plus 6 is equal to 6 plus 5. Okay? Now, more than likely, you knew that 5 plus 6 is going to give you the same answer as 6 plus 5. That is a rule that you guys learned in elementary school, probably at an early age. Okay? But it has a property name, commutative property of addition is very important, of addition. Okay? Because it's talking about addition. All it's saying is that you can take two numbers and move them, or in this case, flip-flop them around an addition sign, okay, switch them when you're adding them, and it still gives you the same answer. They're equivalent. They're the same. Okay? So, let me give you guys another example to write down. X plus y is equal to y plus x. So you have a couple of variables going on there, right? X plus y equals y plus x. Same kind of idea. You have an x and a y, and they're flip-flopped around, switched, but they're still equivalent because they're being added to each other. Now this one's a little more challenging, but the same idea. Take a look. You have something in parentheses, 4 plus a. That is basically one value because of the parentheses. You have a 5. And take a look on this side. They took the 4 plus a, put it up front, and took the 5 and put it in the back of the addition sign. They're still equal to each other. So yes, you can have a small algebraic expression in parentheses, flip-flop the two around an addition sign. You're still talking about commutative property of addition. Okay, questions on commutative property of addition? Okay, here we go. Here's the next one. Commutative property of multiplication. Everyone? On your homework, we'll talk about this probably a couple times in this lesson. On your homework, please, 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 if you see something that has commutative property, do not write just commutative property. Okay? Because while it's like saying someone's first name, but you need to verify that it's that specific thing that you're talking about by saying their last name, right? Well, the same thing could be said here. These two properties, while they share a common main part, commutative, they're different properties. Okay? One is of addition, one is of multiplication. So don't forget that. All right, here we go. This is actually the same idea. That's why it shares the commutative part. 7 times 3 is equal to 3 times 7. So 7 times 3, right? If you simplify it, it's 21. 3 times 7 is also giving you 21. Same idea. If you flip-flop the numbers, switch them, make them travel, they're going to give you the same answer when it's multiplication. I've actually used the word, if you have been listening in the first semester, I've used the phrase commutative property a few times. It's because I talk about, for example, when we talked about integers, I talk about subtraction. I said, guys, there is no commutative property of subtraction. Well, this is what I'm talking about. Meaning, when we were talking about it, 3 minus 1 gave you 2, but 1 minus 3 did not give you 2. Okay? So those were some examples of when I said commutative property of subtraction. There is no such thing. Okay? Just of addition of multiplication. So let's go on to an algebraic form of this. X times y is equal to y times x. X times y is equal to y times x. Okay, and I don't want this to confuse you, so that's why I'm putting it here. Instead of the multiplication dot, you can have parentheses. That still says a times c is equal to c times a. Okay, just because it has parentheses doesn't mean it's not multiplication. They're flip-flopped around from one side of the equal sign to the other. So there's only commutative property with addition and multiplication. Okay? So those are the first two properties. Okay, questions on commutative property? Okay, here we go. Our next property is called associative property of addition. Everyone?
Associative property of addition.
Okay? So we're going to kind of do, to help you out to remember these problems a little bit, we're going to do the same thing that we did last time. That word associative comes from which word? Root word? Associate. Okay? So listen, I don't know how many of you guys have had this. I heard it a couple times in my life, and some of you guys may have had this, but you go home, maybe after a time of like making a wrong choice, maybe getting in trouble or something, and your parents say something like, you should not hang out with those kids anymore. You should, no, you've got to find yourself better students to hang out with. Okay? Sometimes happens. All right? What they could say is you need to associate with another group of students. Okay? So associate means basically connect yourself with someone else in some way, somehow. Okay? And that's actually what this is connecting something with something else. All right? Now, what does that mean in math? Well, let me explain. Go ahead and write this down under your window first. Oh, that did not. Go ahead and write that one right there. So write down 4 plus 7 plus 2 equals 4 plus 7 plus 2. All right, it's addition. And then I want you to put the parentheses around the 4 plus 7 on the left side of the equal sign. On the right side of the equal sign, put it around the 7 plus 2. Okay, so remember I talked about like your parents saying you should associate with another group of students, to connect yourself with something else. Well, what this is kind of saying is this. The way this is written, it's saying the 7, because remember order of operations, you have to solve what's in the parentheses first. It says you can add the 7 with the 4 first. But if you decided to, you could associate the 7 with the 2 first, meaning you could add it with the 2 first. It'd be up to you. And bottom line is that no matter what you do, because it's all addition, you'd get the same answer. And that's what the associative property of addition says. It says if you have a long list of addition, you can add it whichever order you want. You can associate numbers with it, whichever other number that you want when you simplify it, and you get the same answer. It doesn't matter. And that's kind of the bottom line associative property. When it comes to the property, it's written like this, usually with parentheses, saying you could take like this, the 7 and add it with the 4. You could take the 7 and add it with the 2 first. It doesn't matter. Okay? Now, I'm a little disappointed because it looks like when I printed this out, the PowerPoint changed it. But go ahead and write this down. I'll go ahead and write it down like this. Okay? This is the algebraic form. So A plus B plus C equals A plus B plus C. And on that one, the parentheses around the A and the B, right, on the left side, and then on the right side, it's around the B and the C. Meaning you could add the B with the A, you could add the B with the C first, it doesn't matter. As a matter of fact, a little extra is that you could, if you wanted to, even though it's not shown like that on the property, you could even add the A with the C first, and then whatever you get, add it with the B, if that works. Okay. So associative property of addition. If it's all addition, it doesn't matter which order you add it. You can add it either way. Okay. Okay, next is associative property of multiplication. Everyone? All right, so go ahead and write that down right there. 6 times 5 times 7 equals 6 times 5 times 7. You guys probably see a little bit of a pattern going there. Parentheses around the 6 with the 5, or parentheses around the 5 and the 7. Does this problem look familiar? It's the one we did to open up the lesson, right?
Yes.
That's kind of what it is. So if they gave you a problem like this, okay, you're probably best doing that way, right? You want to multiply the 6 and the 5 first to make it 30. 30 times 7 is 210, so it makes it a little easier. Okay, but I use the associative property of multiplication to be able to solve that problem, make my life a lot easier. Okay, now algebraically, you can go ahead and write that next one down right there. A times B times C is equal to A times B times C. So you can multiply the A and the B first, or the B and the C, it doesn't matter. So hopefully, if you remember what the word commutative or commute means and the word associate or associative means, you will actually have a good idea of what half of your properties are, because those are, of course, 4 out of our 8 properties that we're going to talk about today. Okay, so let's go ahead and do the rest. All right, now these are going to be a little different. Okay, here we go. The next one is distributive property, everyone? Okay, now on your notes, I don't have that. I wish I did. I don't have those notes on my laptop, otherwise I would change it. But if you take a look, they put distributive property of multiplication on one and distributive property of addition on another. Here's what I want you to do. Where it says of addition, take your pencil, scribble it out. Where it says of multiplication, take your pen or pencil, scribble it out. The of multiplication part, or the of addition. So it just reads distributive property. Okay? Now, here's why. Because with distributive property, you are going to see addition with even some subtraction at times, along with multiplication. That's what makes up distributive property. Now, if you take a look at Friday's lesson, right, that's where we're going. We're actually going to have a couple of specific days just for distributive property. This is a special property we're going to go into more detail on as a 7th grader. So we're not going to spend a lot of time on this for right now. Okay, if you notice in the notes, right, it says of multiplication and addition. It just means that it's the same thing. So here's what you can do. You can open up both windows if you want, or you could just do it under one window, and under the other distributive property window, just put like C other distributive property or something like that. All right, so here's what all I want you to write. We'll talk more about this. This really isn't in your homework very much tonight, if at all, but I just want you to write this to have it down in your notes. So 2 times and then x plus y is equal to 2x plus 2y. Okay, and like I said, right, I don't want to spend a lot of time. We'll talk more about it in a future lesson. This is just for the sake of having it in your notes. Okay. Okay. Here we go. The next property. Additive identity property. Everyone? Oh, let's try that one more time. Additive identity property. Everyone? Additive identity property. Okay, now some of these will be a little weird because they actually have a couple different names. It's also known as the identity property of addition. Okay? If you take a look, right, they both have the word property, they both have the word identity. They just put additive as like an adjective instead of addition, but it's the same thing. Okay? Talking about like root words or just the meaning of words. Identity. You guys have a little card. What's that card called? An ID card, right? An identification card, or an identity card. Okay, whose picture's on it? Yours. Okay, so when you talk about, and this is maybe a little corny way of remembering, but when you talk about identity, it's about you, right? It's about you. So if you're talking about identity, let's just, and again, this is more of a corny way of remembering this, if it helps out a little bit, but when we get up in the morning, if you actually decide to brush your teeth and comb your hair before coming to school, okay, maybe wash your face out a little bit, and Where do you see yourself in the morning? In the mirror, right? In the mirror. Some of us may not look in the mirror, unfortunately, but some of us probably should start looking in the mirror maybe in the morning. But I'm joking. So, who do you see on the other side of the mirror? You see yourself, right? That's what I'm saying. When you look in the other side of the mirror, you see yourself. So, here's what I want you to know, okay? I'll come back to this. For right now, I want you to go ahead and write this down. This, again, remember we talked about this at the start of the lesson. 5 plus 0 equals 5. Now, here's what I always tell my students. Pretend like the equal sign is the mirror. On this side is 5. On this side is 5. But look, additive identity property, meaning what can you add to one side to get it to be the same on the other side of the mirror? What are we adding to the 5 to get it to stay 5? 0, right? So that's what I'm talking about. So identity property of addition, or additive identity property, just basically states what we kind of started the lesson out on, and that is you take any number, you add 0 to it, you get the same number on the other side. Okay? So that's what identity property of addition, or additive identity property is. So algebraically, something like a plus 0 is still a. So a plus 0 equals a. Okay? Next is the multiplicative identity property. Everyone? Oh, come on, you got to say this word. It's a great word to say. Multiplicative identity property. All right. It's also known as identity property of multiplication. Now, let's think about the meaning of the additive identity property, or the identity property of addition. Remember, it's what do you have to add to get the identity, meaning the same number on the other side. Well, in this case, what do you have to now, don't shout something out. Think about it first. What do you have to multiply by to get the same thing on the other side of the equal sign?
1.
Very good. I have people go 0. They shout it out without thinking. It's like, wait a second. 5 times 0 is not 5, right? So yeah, you're absolutely right. You multiply by 1. So this property is saying just that. If you take a number, you multiply it by 1, you're going to get that same number. You're that same expression on the other side. 8 times 1 equals 8. Algebraically, right? You could have something like 3 plus c in parentheses. That expression times 1 is going to be equal to that expression. You take anything like that, you multiply by 1, you're going to get the same thing on the other side. And here we go. Last one, multiplicative property of 0. Everyone? Also known as 0 property of multiplication. So, we just talked about this, right? Multiplication, 0. What do you think that this states? Multiply by 0, your answer is 0. Yeah, you guys are absolutely right. So 12 times 0 is 0. 12 times 0 is 0. You can have something like y times 0 is 0. You know, anytime you have something like that, you can even have the expression like 5y times 0 would be 0. You multiply anything by 0, you're going to get 0. Okay, before we go on to our examples right now, what I want to point out is this. If you take a look, every single property we talked about, I compared both sides of the equal sign, right? You're saying, well, what's the difference between this side and this side, right? And then you're seeing that, well, you know, you're multiplying by 1 here, well, you get the same thing. Here, you add a number to 0, you get that same thing. So you're looking at both sides of the equal sign. Well, that's a huge part of what we're about to do. Okay, so what I'd like you guys to do, since we're done with our vocab, is to go ahead and grab your homework sheets. Okay, you can just push your vocab to the side for right now. Okay, you don't have to, we'll put it in our binders in a bit if it's not already in there. Bless you. Okay, so here we go. Go ahead and grab your homework. Get your name, date, and period up at the top. Okay, here we go. We're going to go ahead and, by the way, I just want to point out, okay, they're both lesson 3, right? Chapter 5, lesson 3. That's why it's called 5-3, okay? But if you take a look, one side is skills practice, the other side is homework practice. Okay, we'll be going back and forth between the two. All right? So let's go ahead and start on the skills practice side. And let's take a look at number 6. And I want to start with number 6 for a couple of reasons. First of all, I want to share with you guys, okay, there is a missing set of parentheses there, so you might want to write that down. Okay, here we go. With problem number 6, okay, here's what you're going to do on all of these. Now, this is, like I told you, this lesson's a little different, or the homework's a little different than usual. This is a lot, not all of it, but a lot of it is about vocabulary. And vocabulary, think about it, in AB class, if your teacher has on a homework or a test that says define this word, okay, well, what are you doing? You're just giving the definition, right? And that's kind of like this. Or if they give you a definition, they say which word goes with this definition. It's not like you have to do a bunch of calculations to find out the word, right? It's like you know it or you don't. Now, you have to do some thinking, and our steps, most of our steps anyway, has to do with how to think. So a lot of this, the steps I'm showing you guys, is mental steps, all right? So some will take you 1 second, others might take you 5 to 10 seconds to actually do it, all right? But here we go, follow along. So step 1, and this is such a half a second kind of step, find your equal sign. Because remember, we were just talking about it. You're finding out what's going on, what's the difference between the two sides here. So to be able to know the two sides, you have to find your equal sign first. Okay? Then comes step 2, and that is take a look at both sides. And this step 2 may take you 15 seconds. Observe it, look at it, study it, and I'm not saying like study for hours or anything, just look at it, observe it, see, analyze it. What is the difference in the two sides? Well, if I look at the difference here, you cannot say that the parentheses did move, but that's not the only thing that moves. So be careful. A lot of people go, oh, it's associative property. Well, no. Be careful. Here's what happens. I have m plus 2 plus n on this side. Take a look. It's n plus m plus 2. The m plus 2 are both still in the parentheses. What happened is this expression here, and that n switched around the addition sign here. Okay? So what you're going to want to do next, if it doesn't pop into your mind, is do step 3, and that's refer to your notes. Look at your examples if you don't already know what the answer is. Okay? Now, step 4, hopefully by now, either you knew it or you're from the vocab lesson or you've just looked in your notes and referred back to it. Step 4 is you're going to give the answer. Now, here's what I want you to do. Put a little asterisk by step 4. Okay? Because here we go. I'm going to repeat what I said earlier. First of all, they switched around the addition sign. They moved around the addition sign. They commuted around the addition sign, right? Ladies and gentlemen, this is the commutative property. But the reason why I put the asterisk is this. It's the commutative property of addition. I'll let you put an addition sign if you like. This is the commutative property of addition. Ladies and gentlemen, if you do not put of addition, you will get it wrong. Okay? Because I won't know if you mean of multiplication or of addition or what. So make sure you don't forget that last part. Okay? Step 1 should take you half a second. Step 2 might take you 10-15 seconds. Just really look at it and notice. Step 3 you may or may not have to do, depending on if you already know it. And then, of course, just be careful with step 4 once you write down your answer. Okay? All right, before I let you try one like that, any questions? Okay, so on the same side, I'll give you about 30 seconds. Go ahead and try out number one. Now listen, before I have you try it out, when we share in just a bit, you share with your neighbor, I'm going to want you to say what's the property, but how do you know it's a property? Meaning, you're going to want to say, like, what's the difference? What's happening from one side to the other? Okay, you have to back up your property with why, okay, when you share with your neighbor. So keep that in mind when you're solving the problem. 30 seconds. Go ahead and do number one. Go. Okay, how many of you need more time on number one? Okay, so again, when you share with your neighbor, I want you to not only share the property, but because when I pull a stick in just a second, I'm going to ask you what's the property and why is that property. So if for some reason you don't know what it is, make sure you talk to your neighbor about it and then learn from them. Okay, so here we go. 30 seconds. Turn to your neighbor and share. Go. Okay, so I'm going to pull a stick. I'm going to ask this person, of course, for the property and why is it that property. Okay, and then when you agree or disagree, if you agree, that means that you agree with not only their answer of the property, but also their explanation of why it's the property. If you agree with the property, but their answer doesn't make a lot of sense, then give it a thumbs down that you disagree. Okay, if you feel like your explanation is a little clear. Okay, so here we go. Seat number 25.
Commutative property of multiplication is the numbers moved around the multiplication.
Commutative property of multiplication because the numbers moved around the multiplication sign. Okay, agree, disagree. All right. Nicely done. That's exactly what happened, right? 9 times 6 is equal to 6 times 9. It's saying that it doesn't matter if you switch them, they're the same. But I do like the way that your classmate said that it is around the multiplication. That the switching refers to this. The around the multiplication, when Nico said that, meant around, it's a property of multiplication. So that was really important on the explanation. Okay? Because it's very easy to put commutative property and then just go of addition, and then you're not even looking at the sign. So be careful of that. Okay. All right. Nicely done. All right. Those of you that most of you guys agreed. Any questions, guys? Okay. Let's try another one that's very similar. Let's stay on the same side. Let's take a look at the problem right next to that. Okay. Problem number 2. Okay. So you're going to just see me go through the steps again. So here we go. Step 1, right? There's our equal sign right there. Step 2, what's the difference in both sides? Well, this side is m. That side is m, but we're just adding 0. Well, the addition is 0, remember. It's the property that says if you take something and add 0 to it, it's going to be the same thing on the other side. Oh, the same thing on the other side, and, it's adding 0. Okay, and remember that was talking about the ID card. It is the identity property. Okay, if I didn't know that, I could have looked in the notes. Okay, the identity property. However, don't forget that part of step 4, right? Adding 0 is identity property of addition because you're adding 0 to it to get the same thing on the other side. And that's the identity property of addition. All right, so just another way of just going through the steps. I just went through all 4 steps that fast, okay? Again, if you have to refer to your notes, then that's okay. All right, any questions? I'm going to have you try another one. All right, on yours, here's what I want you to do. Flip over to the homework side, homework practice side. I want you guys to try out problem number 1. Problem number 1. Okay, go. All right, how many of you are still working on it? Okay, all right. I'll give you guys, check in with another about 15, 20 seconds. Anyone still working on it? Okay, so remember when you share, again, make sure you share with the person what, which property is it, but how do you know? Okay. All right, so here we go. 30 seconds. Go ahead, switch to your, turn to your neighbor and share. Go. Okay, here we go. In other classes, this problem is kind of brought up a little bit of discussion. It's a good, healthy discussion. Okay, and I don't know if it'll come up in this class, but we'll see. All right, so problem number 1, seat 30.
Identity property of multiplication says it's 1 times a plus 3 and 1 is equal to.
Okay. So 1 times a plus 3, and so multiplying by 1 gives the same. All right, so identity property multiplication. Agree, disagree? What do you guys think? Okay. All right, did anyone have something different that is brave enough to share? Savannah, what do you have? Okay, why distributive property? Okay, just a quick show of hands. How many of you guys ended up with distributive property? A few of you guys? Okay, believe it or not, you guys are correct as well. It's a little hard to explain. I wouldn't have interrupted you, but it's a little hard to explain, right? Because we haven't talked about distributive property very much. It actually could be distributive property as well. And we'll talk more about that in the future. So that is the, I think the book wants you to identify it as identity property multiplication, and that's what it will be on our key when we correct our homework. But distributive property is also be distributive property as well. Okay, depending on how you use it, how you look at it. So so nicely done. All right, that's the big discussion in some of my other classes because it could be either one. And you'll find out on some of these problems we're about to do that you might have more than one answer that gets the job done or that makes sense. So, because some of the properties, believe it or not, are kind of interlinked in some ways. So, so that would be okay as well. Okay. All right. So it looks like between the two properties we were okay. So any questions on that one? Okay. All right. So let's stick to this side. Let's go ahead. Now what we're going to do is we're going to take the idea of properties and we are going to, we're actually going to use them, all right, for the second half of the lesson. So what I mean by that is I'll show you what I'm talking about. Let's stick to the same side. Let's take a look at problem number 9. Let's look at number 9. Now the directions say simplify each expression. Justify each step. Now this is the first time we've seen this, but you will have this on our upcoming test. And we'll actually spend a whole day towards the end of our chapter talking about this when we learn all of this chapter skills about justification. Okay? So basically, guys, justification is basically giving your explanation of what you just did. Okay? So that's kind of what we're doing. So here's how you're going to do this on your homework. So let's go ahead and do this. Okay? So I'm going to just rewrite this problem. 2d times 3. Okay, now what I want to recognize is that this is all multiplication. 2 times d times 3. Okay? So, when I go to solve this, okay, and I guess if we're going to put steps on this, I guess you would just say, you know, observe this if, or you could just say really look at this problem, okay, because this problem, you need to study it. Okay, kind of find out what is it, because some of us still aren't comfortable with parentheses, with a lot of other things going on. But in this case, 2 is right next to the d, that's multiplication. D is right next to the 3 with just parentheses separating it, that's multiplication as well. Okay, so after we sit there and we look at it, all right, we're going to go ahead and we're going to come up with a plan. Okay, and in that plan means look for a property that works. Well, considering that it's all multiplication, our properties, it has to be one of our multiplication properties, right? It can't be a property of addition. There's no addition there. So it has to be some property of multiplication. So in this case, it could be commutative, associative, you know, identity, okay? So you have to kind of decide which one to use. Well, in this case, here's what I'm going to do. I'm actually going to take the d and the 3 and flip-flop them. So here's what I have. 2 times 3 times d. And when you come up with your property, write it down. That's your justification. All I use when I flip-flopped it or with using multiplication, this is the commutative property of multiplication. Now, what I'll do is I'll just say step 3, bless you, and it is basically repeat both steps. So, you know, now look at this, come up with a plan. It's all multiplication still, but here's what I want to do. Instead of a property, this isn't necessarily a property. Here's all I'm going to do. I'm just going to multiply those two. 2 times 3 is 6. So we end up with 6 times d. When I did that, that's not a property. That is called simplify. All right, it's a word we've used all year long. It's just an expression, right? There's no equal sign, so we simplify it. We just simplified 2 times 3 to get 6d. Now, do we know what d is? No. There was no one defined the variable, right? So, unfortunately, we can't go any further. This 6 is now our coefficient right in front of the d, and that's as far as we can go. We're done. That's our answer. Okay, remember a second ago I said, guys, there may be more than one answer. Here's what I'm going to share with you some other answers that students have come up with. They said, well, Mr. Wilkins, what I did was I pretended like the 2D was an actual expression by itself, and I flip-flopped 2D with the 3. So here's what they did. They took the 3, put it out front, and put the 2D behind it. I said, that's great. That's still commutative property. So you would still write it like this, write commutative property of multiplication. Then you would still simplify, and you still get the same answer. And that works that way too. Someone actually said, well, Mr. Wilkins, what I did is, since it's all multiplication, and you said associative property multiplication says you can do it in whichever order you wanted, all I did is I took this whole thing, I used associative property and multiplication, and just multiplied my 2 with my 3 first, and got 6D right off the bat using associative property and multiplication. And I got my answer. And I said, that's perfect. That works too. So you see how you can use different properties to simplify, to your advantage, to simplify certain expressions. Okay, using some of those different skills or strategies. Okay, so any of those would work. Okay. All right, any questions on any of the steps, anything I just said before I have you try one of these? Okay, here's what I want you to do. Go ahead, take the paper, go back to the skills practice side. Okay, I want you to do problem number 9. Problem number 9. All right, try that out. Go. I'm going to be passing out your guys' logs, so you don't have to worry about passing them back yet. Just make sure you're working on the problem. How many of you are still working on that? Okay. Again, guys, if you're not done with your work, please just leave the logs, okay? Your number one priority is to get this problem done. Okay, how many of you are still working on it? Okay, about 15 more seconds, then I'm going to have you guys share. Okay, 30 seconds. Now, during this, again, you'll need to probably share your work with your neighbor, and then, of course, share which property it is, right? Because you need to actually see the work and what you're doing to the problem to be able to get the final answer, okay? So, 30 seconds. Go ahead and share your work with your neighbor. Go.
So what mine, I thought communitive property is like 3 plus 2. I put it in this front, so it's all
Okay, what I was talking about earlier is it is quite possible that you and your neighbor did it differently, and yet still got the correct answer, and still got a, both of you guys did differently, still got the correct final answer as well as all the correct justifications and everything. Okay, so for number 9, 5 plus b plus 2. Okay, so, and someone asked me yesterday, said, Mr. Wilkins, so when we correct this on tomorrow's key, is it just going to be just the answer? I said no, the justifications, your work and your answers, it's all part of your answer. So you have to get it all correct. You can't just end up with one answer, and you have to have justifications in there. Okay, so here we go. I'm going to go ahead and start off with 5 plus b plus 2 in parentheses. Now when I look at it, I realize first of all it's all addition, but we have these two things set in parentheses. Now there's a couple of different ways I can look at this, but here's what I'm going to do. I'm going to turn around. I'm going to keep it as 5 plus parentheses. What I'm going to do is I'm going to take these two and switch these two inside of my parentheses. What I just did was switching them around the addition sign. I just did the commutative property of addition. Okay? Then what I can then do is this. I'm going to add these two first, but that doesn't work. We can't add the 2 plus the b. But I can add the 5 plus 2. So here's what I'm going to do. I'm going to take these parentheses and put them around here to add those two first. When you add the 2, instead of adding it with the b, I add it with the 5 instead. Remember, it's to associate the 2 with the 5 rather than the b. That is the associative property of addition, of course. Don't forget your addition. At this point, there's nothing else I can do. I can just simplify this. So what I end up with is 7 plus b, and I just said what I just did, right? I simplified. And we can't add those two because we don't know what b is, and so there's our answer. All right. Anyone want to share something to see if they got theirs right and you had something a little different? Okay. Okay, we do have one more type of problem, but it's very similar to this. It's more of a word problem though, and it's actually not. It's kind of very much like how we started this lesson. So we're just gonna. It's like that on your homework. So here's what I want you to do: is flip over to the homework side. Let's take a look at number 11. And go ahead and close read this with me. So the topic is faxes. All right, so here we go. Marcella sent 4 faxes to Jim. The first fax took 14 seconds to send. The second fax, 19 seconds. The third, 16 seconds. And the fourth, 11 seconds. Use mental math to find out how many seconds it took to fax all 4 documents to Jim. Explain your reasoning. Okay, so listen. Now, what I'm going to do is it says use mental math. The funny thing though is when it says explain your reasoning, it's saying to like write down how you solved it. So even though you can use mental math to get the answer, okay, they want you to kind of explain it. And you can explain it in words if you want. For some of us, it's easier to explain by showing the problem that you did in your head. So, I mean, here's what I'm thinking first. First of all, it's just asking how long did it take them to fax all 4 of them? Well, I mean, guys, it's 14, right? Plus 19, plus 16, plus 11. But in my head, I know this is 60 seconds. How do I know it that fast? Because here's how I know it that fast. I can use commutative property, or you can even say associative property, and associate the 14 plus the 16 first to give us 30, and the 19 plus the 11, and that gave me 30. And I know that 30 plus 30 is 60 seconds. So it's not asking me to justify with a property, okay? but it is telling us to use a property to solve it. Kind of like what we just did, but you don't have to justify. And it's a word problem. So you're still kind of doing it very similar to number 9. And that's why I didn't write steps, because it's very similar. Bless you. Okay. Any questions on that type of problem? Okay. I'm going to have you guys try one. All right. Try out problem number 11 on the skills practice side. Skills practice. Okay. How many of you guys got 6 inches? 7 inches? 8 inches? 9 inches? Okay, some of us, so looking at that, okay, here's what I'm looking at. All the numbers, I'm trying to match them up somehow, some way to make this mental math. Well, if I take a look, if this was 26 and 14, I'd match those two up. Why? Because 4 and 6 gives me a set of 10. That's why. 3 and 1 is already, 2 and 1 is already 3 with the extra set of 10, right? So these two right here, instead of 40 though, it'd be 4.0 because of the decimal. And look at here, same thing. 5 and 5 is an extra 10 with 2 and 1. That's 3 with an extra 10 is 40, or in this case, 4.0. So you add those together, we get 8. And of course, don't forget your units, right? It's a word problem. 8 inches. Okay. All right, guys. It's all on property.